Good evening, everyone. And my name is Dr. Mohd Baqer. I'm part of the team starting a center for the Internet of the Future. Today's applications are mainly targeting today's customers, but in my slides, you'll see that this trend is going to change in the future. We're going to have different type of communication, different type of services. So I hope that my presentation will deliver this today. The agenda for today, I'll just have a short background to the problem or the problem we have. I'll define the concept of something called the Internet of Things, and then I'll talk a little bit about the enabling technologies and some of the applications and challenges that we have in the application of Internet of Things. So, 60 years ago, computers were large machines, not very affordable, needed a lot of people to operate them, very complicated things. Today machines, small, affordable, you can buy them off the shelves, very easy to use. So there's a change. You can see there's change from not affordable to affordable, large size to small. The change is going. Services that we have on the internet is actually a suite of services. We have instant messaging, content, social networks, e-services, e-commerce, and so on. There's a lot of services. All of those services will also change in the future. So what will make this thing, the internet of today, change to the internet of the future? One of the things that's going to make change it are two concepts that we have here. And the initial concept is something called microscope. Microscope was let's say, science fiction. They said that we want something to be able to know about everything. This concept was actually kind of achieved or developed into something called ambient intelligence. In ambient intelligence, we don't only want to know about everything, we want also to interact and change everything. So a little bit expanded our scope there. At the end of the day, all of our work in the computer science or ICT, we want to achieve Mark Weiser concept or statement. He wants to see all the machines, not only small, he wants to see them embedded in our fabric, in our clothes, in our bodies, in our buildings. So we won't be even carrying machines anymore. Machines will interact with us seamlessly. The Internet of Things, which is one of the Internet of the Future concepts, it's not a very new concept. It started in 1998. Basically what they mean is that you have objects, chairs, trees, plants, aquarium, chairs, embedded with some wireless capability, some memory, some processing, some battery, and then they can communicate with you and with other objects to make your environment easier. We're going to see how this can happen through the applications I have in my slides. Why is it important to talk about this kind of things? We can see that today we are targeting about 5 billion or 6 billion people. We want to make them buy our applications. But with the Internet of Things, we have about 50 billion applications or objects that we want to interact, make them work together, buy our applications. We have different types of communication. We have human-to-human communication, human-to-things, and things-to-thing communications. So the demand on the infrastructure will also change. How much bandwidth we need, how much resources we need online will also change. Two enabling technologies are RFID, which existed for a while, and something called WSN or wireless sensor networks. The difference between the two, that wireless sensor network has memory processing, battery, and wireless capability, which is much powerful than RFID. So we're going to see much powerful application as well. Sensors being with us for a while, you can find them in your car, fridge, TV, all kinds of security systems. So we don't really need to invent the wheel. The systems exist there. We just need to make them connect and talk to each other. What kind of application we can see? You can see applications in industry, agriculture, leisure, cars, and so on. One of the applications that just popped in my mind, if you have a strict diet or some kind of, let's say, you want to lose some weight, you can download, let's say, a program or a plan to your iPhone, and every time you eat something, you scan the barcode, and it will tell you, should you eat it or not, or should you have had enough of it this day or not, and so on. Another application, instead of going around a shopping center, your clothes will actually convey messages to the shops and then direct you exactly where you can find the best offer that suits your style. So it's very, very good. Instead of walking around, you just go to the places where you actually find your clothes. If you have a long weekend and you have a fish at work, you're worried that the fish may not get enough food, you have a system that will detect that you haven't fed the fish and will feed it on your behalf and send you an alert so you keep track of how much food you actually gave the fish. More serious applications, you can find them in environmental monitoring. You don't want to go and be very invasive on the very sensitive environments. You put some sensors. You put some sensors here and inside the nest, and they start monitoring bird nesting. In the Great Ocean, the Great Barrier Reef in Australia, they have this kind of monitoring stations where they monitor the temperature differences and how they affect the reef, because the reef is dying because of the global warming. So they try to see how much change is actually happening. Urban monitoring, you want to find the car park very quickly. You have the sensor nodes embedded in the car park. Before you arrive, it will tell you that you should go and use this car park, this level, instead of you going and searching for one. So we have a lot of applications, healthcare, a lot of demand on hospitals, so why don't we take healthcare back to homes? We have a lot of sensors conveying heart rate, pressure back to doctors, back to nurses, and sending patients immediate responses. Elderly can benefit from, for example, reminding them of pills, medication, and so on. I have a very small application here we developed at the University of Bahrain. The cost of the sensor is about like $1 dinar or less. We connect this sensor to the computer, and what will happen is that it will measure the temperature in my room and give it back to Twitter every 30 minutes or 15 minutes. The importance of this kind of applications, if you have a very strict, let's say, a refrigerator with some biological equipment or something that requires very sensitive temperature, you can immediately monitor them and get it to your social network. If you have a colleague that stays next to you in the, let's say, university, he can also follow your page, and if you have a problem, he can assist you of opening your door and taking your equipment to a better place. So this kind of applications, we're going to see more of it in the future. We have a problem. We solve it by introducing Internet of Things, but the problem is we're going to create more, let's say, challenges. We're putting a lot of information on the website. Not information created by users, but information created by objects. So now the chairs, rooms will tell information about you existing and then convey it to the internet. So you have a lot of issues in regard of security and privacy. Maybe you don't want the objects in this room to tell that you're sitting here. So we want to control this kind of thing. Standardization and governments, because this Internet of Things is very, very new, having been developed into a standard, so there's a lot of work on that. Of course, not only users are using the internet objects, so there's also a lot of demand on the infrastructure. The bandwidth that we have today may not be enough for all the objects connected in the future. Finally, in conclusion, we have created the Internet of Things. So now we know about anyone, anytime, anywhere, and about anything in this world. Thank you very much.